Okay, this is FlowJo 10.7.2. We've actually are planning a release in about a month, and I was doing a little testing, looking good so far, so we'll go with it. We'll see how it works out here for us. Should be okay. I've got it with a fresh set of preferences, so this should look exactly as FlowJo 10.7 does on your machine. And so we should be good to go in that regard. So let us start with adding a bit of data here. And let me close up the Zoom panel here so I can see what's going on. All right, we'll add just my favorite data set, my friend and colleague Tim's PFIX data set, which we've used in a number of demos. And so I think the important part for compensation here, and let us make our fonts a bit bigger. So quick tutorial and preferences, they're the heart in the upper right-hand corner. And each one of these tabs is a preference, and it allows you to customize some portion of FlowJo. I just use the Fonts tab to make our workspace font a little bigger. The other preference that is going to be of some importance for a compensation webinar is the Compensation Platform tab. So you've always got a compensation platform tab here, a group in FlowJo that will find whatever samples meet the criteria set in your compensation preferences and add those files automatically. The default settings are that somewhere in your $FIL, which stands for file name keyword, the word comp is present, or the word unstained. If you would like to modify these at all, simply just type a different word, hit add to get an extra keyword, an extra box, and type in something that, that identifies your particular samples. A lot of folks, for example, will call their comp controls single stain something, so adding the keyword file name single is a relatively good choice. You can do whatever it is that will make items automatically go into your compensation group, and we can see that I've had 12 items go automatically into mine. Additionally, if there was something that I wanted to add that wasn't added automatically, I can just drag and drop. That works as well. So I don't actually want that FMO control in there, so I'm going to hit delete and take that back out. But anyway, so that's the basics of getting files into a comp group. Once you have a group identified with the word compensation, you are ready to use any of the compensation options that we present. I should mention lastly, let's turn off Outlook so it doesn't interrupt us. I should mention lastly that you can make a group into a comp group simply by double clicking on it and choosing the role compensation. So if you bring in your own folder of data that are specifically comp controls, go ahead and set the role to comp, and compensation will work. Once you've got a group called compensation, or called actually anything you want, once you've got a group with the role compensation and at least 2 samples in it, if you click on it, you'll notice that the shortcut to compensation lights up. Or if we go to the cytometry band, you'll see an icon for it that does the same thing right there, and you can press either one to get started. So let's hit the 2 overlaid Gaussian distributions here, and we'll get something like this pops up on the screen. All right, so what has happened now in FlowJo is that we've gone through all of the samples that are in the comp group, and we've attempted to automatically assign them to a particular parameter. So we've got samples that are going to serve as exemplars of this file has only one color in it. This is a single stain control. This is what cells stained with only this color look like. We can use the fluorescence in every other channel as an exemplar of how much AutoSpill we're going to see. Sorry, how much spillover we're going to see. We'll come to AutoSpill, I promise. How much spillover we're going to see in all of the other channels so that we can subtract it out. Okay, so right here's a list of the parameter and the sample that we think is the best example of a single stain control for it. You'll notice that you've got colored markers next to each item in this list that range from green here to yellow, but red would be a possibility also. You get green if we have, let's skip past the live dead marker. That one will be an exception that we'll come back to. But you've got green if we found a nice bright peak and the name of the parameter is somewhere in the file. And so here we go with the APCH7, looks good. FlowJo is fairly confident that we have done this correctly, so you get the green go light. You get yellow, and if you mouse over it, a message that goes along with it explaining what the hesitancy is if one of those 2 things weren't true. So in this case, for the Alexa 488 control, we've got that nice bright peak, but we don't have the exact parameter name in the name of the file. And so in this example, A488 was used in the sample, but AX488 was used in the parameter name. As an expert human user, and not a computer just trying to follow some simple rules, we can clearly say, I see what the issue there was, and I think that is in fact the proper sample, so I've got no concerns about that yellow light. So yellow will not mean that there is necessarily a problem. It'll just mean maybe you should look at this one, make sure that it's appropriate. If we go down to the next sample, we will actually see a real problem. Oh, it doesn't appear to be any kind of positive peak in here, and my colleague has labeled this particular parameter blank. It's an unused one. Okay, so if FlowJo gets one wrong, and here it had an extra parameter that I told it to use, and it actually had an extra file to assign it to, the unstained beads. So it did its best, it put that file associated with it, but it's wrong. So we're going to click on this, and you can associate a different file with it, or in this case where we just really don't want to use that parameter, I can say remove. There was another option there for remove all, like unused parameters. We'll get to that case in our next example, where maybe we've got, say, a spectral situation where there's more parameters or more detectors than parameters, and we won't assign a specific control to each one. But here there was just one. Okay, and so bunch of greens, few yellows. We see that pack blue is called PB, so likely that's just fine. Excellent. All right, so we can feel fairly confident that we've assigned the proper sample to the proper parameter in each of these cases. We'll want to inspect it to make sure it looks like everything's on scale, and we've got the same kind of control being used to identify a particular cell by, not a particular cell, but just the particular size and complexity of a cell, so that we can assume you've got a very similar contribution of autofluorescence to the negative peak and the positive peak. In this example, we have universal negatives. We have universal negatives both for beads and cells, and the program has assigned them correctly, actually, to each of the samples, so that we're going to use particles that are going to contribute the same amount of autofluorescence to both of these peaks, and so it'll cancel out when the math is done in the end. It could be that you have a negative and a positive in a single tube. So you've just spiked in a negative into your beads, or used cells that naturally had a negative example in them. So that's fine too. There is no problem with either one. Just the difference will be if you have a universal negative, you'll have 3 plots here, and we'll see the identifier for the blue peak in blue saying unstained beads, and the identifier for the positive peak in green saying whatever sample it is. And that's listed here in the list of negative and positive controls, and exactly which gate is being used as well. If you disagree with any of these, you can double click on a plot to change it. If you want to use a negative that hasn't been used, you could specifically go through your list of samples over here, and drag and drop a population and drop it in a box. So something like that. I've dragged the exact same one in, so nothing changed there. But if you wanted to use a particular population, you could do it that way. That'll work as well. If you had a universal negative you wanted to use for all the files, you could drag it and drop it up to just the negative column header there, and you can see that's highlighted all my negatives. I don't want to do that, so I'm gonna leave that go. Okay. Oops, I accidentally dropped it and add an extra population. Well, we'll just leave that be. Okay. So if you want to change one, and we've got a case we do want to change at the top, the live dead die. And so the live dead discriminant here, well, we don't have a very strong positive peak, and we suspect that's because auto gating, where we're trying to identify a nice bright live population with lots of cells, has probably identified a population fairly lacking of dead cells. So I can double click on this plot and say, let's move our cleanup gate down to where there might be some dead cells. And sure enough, there we go. We got a nice big peak that's popped up. Okay, as you may know, we would really like to match the cleanup gates that we're getting the same contribution of autofluorescence, and they don't match now. I could go into the unstained cells and move that gate to make sure it matches this one, and that would work for this sample, but I do have some other samples that are using cells that use that unstained cell control, and I probably don't want to move it for all of them. And so perhaps in this particular file, I can see that this is cells. There are some live cells still in my cleanup gate there. I can probably just use the in sample negative here. So I'm going to say FlowJo that effectively is now my positive peak. Here's my negative peak. I'll call it something that I can recognize like neg. And then from the list, tell it not to use the universal negative here for cells, but to use the negative population. Okay, so there we go. We've got it finalized up here. Finally doesn't mean you have to be done. You can continue editing if you'd like, but you can generate a matrix just by hitting go at this point. And so here's our basic, the basic process. If you've got the same number of samples as of single stain controls as you have parameters, the same number of detectors of your parameters, everything lines up, you hit go, you get a matrix. This matrix can then be applied to any files just by dragging and dropping of the M here to either an individual file, or I can also go in and drag that M to an entire group if I wanted to. And I've dropped it a number of times, so that's there. Okay, so you can see the red matrix because it's red here, and we could have changed the color while we were building it right there, has now been applied to all these samples. We can preview it by picking any one of our samples and just seeing how it looks. We can turn off the uncomped if we just want to see what the compensation looks like. If we have a gate on a population, which I don't on that, but I know I do on all of the single stain comp controls, so we could preview it on our size gate if we wanted to get a cleaner view of it. Previewing it on a gated population, we've maybe got rid of the dead cells and the debris seems like a good idea. And that we expect dead cells to maybe look a little funky with compensation since they tend to have bound most parameters in unexpected ways. So anyway, we have our comp matrix at the top. You can see the numbers, the amount of spillover that we expect to have to correct out of each one of the parameters. It's heat mapped, bigger numbers get darker colors, and those darker colors are propagated to the preview plot down below, and we will put that back to some actual data. Okay, so you can see if I wanted to check, say that 39.49, which is a fairly dark color, I can hone in on it immediately down here in the bottom. I can zoom in and zoom out to get to these plots in whatever scale I'd like to see them. Okay, there's a variety of views, so n by n view, all by a particular parameter if you want to focus in on one parameter, or you could look at them as histograms if you are so inclined, and in any of them you could also preview the uncompensated. Okay, so that is the basics, but there are some options now. So one thing that I should point out as an option is that you may want to look at the spillover spreading matrix. So SSM is right there. You have the choice to display it or export it. Let's display it. All right, so spillover is how much of a one signal you're going to detect in non-primary detectors. And so it's going to generally add some noise to your data. Spillover spreading is a way to gauge how much, what's the impact of that spillover going to be? How much error do you think you'll see in your data? How hard will it be to gate on a positive population based on how much that population spreads, i.e. gets wider in non-primary detectors due to the spillover? And so bigger numbers are worse here. What this equation is showing is the relative spread normalized to the intensity. And so a brighter color will give a relatively smaller number for the same amount of spread. So just something to keep in mind there. Rule of thumb, something like 5 and below is going to be all right for your spillover. Maybe 5 to 9 is going to be dodgy, depends on the panel. Double digits is certainly too much to use. You don't want to use any parameter combinations that have a double digit spillover spreading number. These are heat mapped as well. This is a pretty nice panel. So the brightest we get is a number, a 2 here that gets into a light pink. And then you also get the sum of both the individual columns and sum of each of the individual rows. So you can gauge the effect of total spillover into a detector or caused by a particular parameter respectively. And so that's a tool perhaps for guiding the next round of panel design. Okay, so I've done this data, I've collected it, I've checked out what my SSM is. Were there any hot spots where maybe an entire column or entire row came up as a bright red? Perhaps I would consider swapping that particular color out the next time I want to build a panel. Okay, so that's one of the more recent tools that we've added. So the other tools that we have in here that we'd like to talk about are AutoSpill / AutoSpread, which is a way to, instead of using gates here to define positive or negative, to use linear regression to do so. And then we can also do Spectral. So I think I would like to switch data sets at this point and go for something more complex to make those tools, to make those tools worth using. That was a pretty nice panel. It was going to work well, basically, no matter what I did. And so let's see, where did I put? Dun, 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 dun. I have a large data set that I would like to use to show this. And I think it was in here. Let's bring that in. Okay, so let's see. Well, 13 controls. Okay, that's large enough, I suppose. All right, I'm gonna double click. One thing I should have mentioned, I'll just do it here, is that you could also, if you want to make your own cleanup gate, do so, and FlowJo will identify it. So if I drop some beads on there, I can do that. And we've applied that control across the board. Okay, and I believe now we've got more in this data set, more detectors than we have colors. And so if we hit compensation, we're going to end up with some empty channels. Oh, sorry, that is not the set that I wanted to use here. That just has the same number of channels as detectors. My apologies. Let's see. Let's try this one. Oh yeah, I think that was it. Okay, 30 controls. Nice. All right, so if we hit compensation there we go. So there are more detectors. This experiment was set up to make use of Spectral. And so you may have a certain number of parameters that you're collecting, and the gist of Spectral is that you're going to use every detector to detect every color. And so let's tell FlowJo actually to use all the detectors as opposed to assuming we're going to want a one-to-one association there. Okay, so FlowJo will do this. And you'll end up with a bunch of empty detectors. And so we're still going to use them. We just won't assign a parameter for them. Like that detector won't be the primary detector that we're going to associate with any particular target. And so if FlowJo's done a decent job, and generally we're okay at that, finding the primary peaks, that might be one that we might want to inject, look at there. Anyway, it's going to assign whatever detector has the brightest signal in it for each one of the parameters, and then we can just remove all the unused parameters. And again, we'll still use all the detectors for calculating the compensation. We are just going to end up with a situation where we'll have one parameter for each single stain control as opposed to for each detector. And so that's just a way to tell us how many parameters we end up creating. I'll make that edit there. And so you'll see that there's a handful of these colors. When you're designing a giant 30 color panel, you're going to have a couple that you're going to probably place in a less than optimal channel. And so I think we see at least one. Oh, there's one that we just gated the negative instead of the positive there. It looks like I'll make some adjustments, at least a couple that are going to be fairly dim. And so, all right, we'll first do this with just pure Spectral, and then we will take a chance on doing AutoSpill. And we'd like that over here and not the stuff off scale. All right, I think that's okay. So to do Spectral, all you do is check the box here, Spectral. And so what this is going to do is now effectively very similar compensation, except that we'll create a rectangular matrix because we will, again, have more detectors than we have colors, and we can say view. All right, there is our spectral compensation matrix being previewed on one of the comp controls. Somewhere in this list, there is a fully stained panel. Okay, so cool, that's plotting in. All the same discussion applies to spectral compensation that it did with traditional compensation. We can turn off the uncomped if we'd like. We could change the view to be focused on a particular parameter or histograms. We can preview populations, et cetera, all fine. Matrix is up top. You will notice it is in fact rectangular. It is immense, but rectangular. Okay, as we've got the amount of signal in each one of the detectors for each one of the parameters, and again, those numbers are different, we could display the SSM just by choosing display SSM button, and same item, look for hotspots. Overall, looks like a pretty good panel. One particular interaction we'd like to maybe avoid, looking at BV710 and BV680. So, when it comes to the panel design, maybe don't put two things that you're going to look for co-expression on those two markers. All right, so Spectral, applied in a very similar manner to traditional compensation. All right, so last, I want to mention that you could do AutoSpill, AutoSpread, and you'll notice that the gates have disappeared. Okay, and we'll remove the universal negative from this. And so the reason the gates have disappeared is that all we're going to do is use the cleanup gates. What we're going to then say is we expect there to be a line that you could plot between the negative and the positive for each one of these single colors. And the slope of that line should be flat. If you've got perfectly lined up medians, which is what you're looking to achieve in compensation. And so we will run an optimization routine where we'll say, okay, let's do a linear regression on the data. How much subtraction needs to happen basically to make sure that that line is flat? And then we'll actually keep running it on the compensated data to make sure that while doing compensation, we optimize it. And then if we view the matrix there, AutoSpill will take a little longer to run because again, it's going to run a recursive process that keeps refining compensation a little more, a little more, a little more on the compensated data, adjusting what the weights are to produce probably the best possible matrix we can make out of this data in most cases. I have run it on beads here. It is better to use AutoSpill on cells as you're going to actually get a better spread of data. You've got a range in the data as opposed to beads will just have the negative and the positive population. One of the real benefits of AutoSpill is that you don't need a strong positive population that stands way out above background or anything. It will just fit the entire range of data that you get, helping making cells the better choice there. Just doing a linear regression on it. And so a lot of these cases where if I'm trying to design an immense panel, it might be difficult to have just perfect control for every one of the colors. AutoSpread and AutoSpill will help deal with that. The AutoSpread is, by the way, what gets displayed under SSM if you're using this particular calculation. One other benefit of using the AutoSpill method is that you can actually go in and assign, and I should have done this if I didn't the first time, one of the colors to be, let's go parameter, choose parameters. I'll just add an empty channel, something that, well, anyway, let's do all the channels to begin with because I just accidentally unselect them. We can put our universal negative, our unstained cells, as one of the channels. And because we can do linear regression on an unstained panel, we can actually subtract out autofluorescence. So again, that will work much better if you have used cells for the rest of these single stain controls, so that you're actually dealing with consistent expression of autofluorescence. But doing something like that on a cell-based compensation approach will then remove autofluorescence via linear regression, and so that's a nice way to go. Okay. Now, sorry, we've started a bit late today and I've gone a little quick through all that. I wanted to make sure I got it in and had time for questions. I want to pull up the chat box here and just see if there were any questions. And if there was not, this is the time, feel free to type them in. I'll also put, there's a QA feature that's built into Zoom. We can use either one of those. So let me know if in this fairly rapid coverage of the options of compensation in FlowJo, if there was anything that you would like to ask about, and if there's anything you would like to see me demo here. We've got about 10 minutes left, so we've got some time. I went quicker probably than was needed actually through that. And I will give folks a moment to type. All right. while we are waiting on questions, I think I will mention thank you for attending the FlowJo home is here. To do under Learn, I'm sure you're here via that tab for the webinars. One thing that I will mention is that once we, thank you for signing for the email list, once we post them, all the webinars go to recorded webinars. And so you can access any that have happened in the past right here. Okay. There we go. We have a question of which is the maximum overlap accepted in the matrix? So it's a good question. There is actually no maximum that just says, you know, this is absolutely wrong. You can't use it. And so what we are, let's see, it looks like I'm running AutoSpill here again. What we are showing in that matrix, you know, you might see a number that even gets up to like 100, 110%. That just means that you had more of the secondary signal than the primary signal in that detector. And so that's okay. We can subtract it out. It implies that perhaps there were some, you know, panel design choices that could have been better, that could have produced a better matrix with less spillover, but there's no number that's just wrong. Probably if you end up seeing a number that goes into the multiple hundreds, you know, 250% compensation, that'd be hard to do, you know, by physics. And so we would expect that there was probably an assignment error somewhere. The wrong file got assigned to the wrong parameter, something like that. So in any case, that's a good question and a frequent one that folks will say, well, I think this matrix might just be wrong. Look, it's got this number here. And so there's no absolute wrong. Okay, so we have a question for, could you please give us an overview about compensation, as I know little about it? Okay, well, that is some extra conversation, but I don't see any other real questions here, so we might as well. Let me try to think if I have a few slides handy that might help with pictures. It's always better to look at pictures. And AutoSpill deck. And I think that's starting. Let's go PowerPoint. Oh, there we go. Okay, so the gist of compensation is that you have, and I might as well go to slide view here, is that you've got a signal. You've blasted a cell with a laser. It was stained with multiple fluorescent probes. Those probes each fluoresce across a range of wavelengths. And we typically have detectors stationed at wavelengths that we assume are going to be good places to collect light for based on our selection of probes. And so this is just a picture here of a BD spectral viewer showing 1, 2, 3, 4 different fluorescent probes and a setup where you've got detectors lined up to pick up the fluorescence from those probes. What this picture is showing is that in each one of the ranges the detector is collecting light from, there's a little bit of overlap from multiple fluorescent probes. And so what we have to do for when we compensate is subtract out the light that came from, sorry, volume down, please. Subtract out the light that came from you know, the non-primary fluor, we call it. If you've got spectral compensation in use here, we would actually lay out those detectors so that we covered as much of the range of light here as possible, as opposed to attempting to line them up to pick up specific colors. So either way, it's about the same of you're trying to identify how much of a specific probe you had on each one of those cells. Let's see. There's also some other questions popping up here about, would the intro to FlowJo 10.7 have instructions on how to set up compensation? Webinar already has compensation set up. Okay, well, let's see. That implies we should also have a basics part for compensation available on the website, something we can do. So anyway, the rest of what we're trying to do with compensation then is define how exactly can we tell exactly how much spillover we have for each one of these detectors. So if we just put in a tube that had only yellow signal on it, then we would see in each of the other detectors how much detected signal there was just due to yellow. So this 530/30 detector and the 695/40 detector would have some signal, and we'd say, well, that's the amount we want to subtract out. And so that is pretty much the basics of what you want to do with compensation there. The gist is that you want to use a cleanup gate, as I mentioned, so that you end up with cells that all have the same amount of autofluorescence, as differing amounts of autofluorescence can throw off the numbers of how much of the signal came from one particular color. And so that was the spot we get to in FlowJo, where, and if we go back to traditional, put gates back on it, where we've got a gate and then the identifying of a positive population, because you'll say, so those cells are the ones that have actually bound the yellow dye, the green dye, whatever it is. And we know that every other amount, any amount of signal we see in every other detector, that is spillover. We've got a question that says, should we avoid changing the numbers in the matrix by checking by eye? Yes, that is a good idea. To not do that, sorry. And so when you are looking at a matrix, and I've futzed with that one, so let's go back to a finished matrix. You'll have all these numbers and they're grayed out to begin with. You have the option to edit. You'll get this warning message that says effectively, don't do this. If I say yes, we make a copy of the matrix, the numbers ungray, and you could actually start just going up a little bit by hitting the up arrow, going down a little bit, etc., typing a number. If I hit enter, that applies that change. So what you're doing there is then telling the software that there are actually, I paraphrased, I think the message says something like, be very careful. But read that as perhaps don't do this. And anyway, what you're actually doing there is saying that there is more of one color and less of another. So that is going to affect the matrix everywhere where those colors are present. And so it is very possible to make a single plot look better while making, depending on how many colors you have, many, many other plots look worse. So if you notice that you've got a matrix that doesn't seem to do a particularly good job of compensating your actual fully stained samples, the first thing to do is to go back to the single stain controls and make sure everything has been appropriately assigned to the right parameter. Make sure the wrong parameter didn't get assigned to the right, to the wrong single stain control. Make sure your compensation controls are at least as bright as the actual data you'll be working on. Make sure that you've got a nice gate identifying positive cells that seems fairly well separated from the negative population. You'll want to start by checking the comp controls. So frequently even you can have good comp controls that don't particularly match your actual acquired data. Say they're all dimmer, for example, or something like that. I think that is the most likely case of compensation looking bad. And we prefer not to just by hand adjust the matrix. It tends to produce unforeseen errors in the rest of the analysis. It also makes it hard to make your work reproducible. Okay, so I think that's the argument against hand editing the matrix. Those controls are in there so that just in case on generally smaller panels, someone has something that is actually generally a fluorescent protein that is very difficult to create a proper compensation control for, that just biologically it's hard. You have some flexibility to go up or down 1% to correct for just being able to not match your actual data particularly well, but we generally recommend against that, and we say that's it's getting to expert level compensation to be able to do that without negatively impacting the rest of your experiment. Okay, so I hope that was a decent quick intro to what compensation is. My apologies for not starting there. I kind of gave that up at the beginning when I thought I was going to run out of time, but we still have 5 minutes left if there are other questions. All right. And I will take it to heart that we could use a little basics tutorial set up specifically for compensation. We'll put that on the to-do list. All right. All right. Thank you very much, everybody, for joining. It looks like the questions have dried up. If you would like to write me specifically, I'm just John, J-O-H-N, .flowjo @bd.com. Let's see, what do you suggest for people like me who are beginners to become experts? All right, well, so practice and finding a mentor is probably the best way to do this. So the panel design aspect of it is, is super important for making compensation easy, in that you'll want to choose colors that don't have a tremendous amount of overlap. That is a separate webinar, and that is definitely something, if you've got like an expert in your core, that I think they can help with. We're working on some tools to assist with that algorithmically as well. But then other than that, I think compensation comes down to following a handful of rules, things like, make it easy for yourself. You are doing compensation so that you can set up a control specifically for the floors. It's not important that compensation be done on the exact same cells that you are going to do your experiment on. People use comp beads, for example, as a stand-in for the cells. What we're really looking to do is see what the ratio is. And so anyway, there's a handful of rules. I would recommend just Googling Mario Roeder. He has a number of papers and also a website, an interactive website, that I think are the basis for how most people have learned to do compensation. So just as a live test on how that works, Mario Roeder, and look at that. Actually, Google even knows that I should ask about Mario Roeder and compensation. And so I think that is a pretty good beginning place right there. And there it is, Mario Roeder. He is perhaps the one of the more respected names in cytometry, and he would, if he ever listens to this webinar, he would yell at me for calling him respectable. But anyway, drmr.com, I believe, has been up for many years and is still accurate. All right, those, I think, a deep dive on a handful of these publications is probably the best way to achieve expert status. And then I think the most important advice that I could give on that is to think through what you're trying to achieve, that it's a control for the fluorochromes, and then set up your experiment so that it's easy. If you end up having a particular set of cells and an antibody that give you a giant spread that's difficult to figure out where positive and negative are, or perhaps your cells are rare and all those kind of things, it's totally fine to use compensation beads that will give you, well-separated negative and positive peaks all the time. Or if you prefer to do cell-based controls, which would be nice for AutoSpill, to put a different antibody on the color that you're looking for. Attach CD45 to every one of the colors that you're going to use, and you'll be able to fill out what the overlap of your different floors are based on that. Even if your experiment won't use that antibody for every color, the compensation controls are the controls for the fluorochromes. All right. With that, well, I guess let's click on compensation Mario Roeders. We'll just show you. I think this was written in, I don't know, 1990 something. Maybe, oh, 2000. There you go. But there's a quiz to see how well you know already, and then an explanation of all the major topics. All right. Thank you for joining us. Take care. Write me at john.flowjo@bd.com with questions, or overall just our tech support team at flowjo@bd.com. Take care.